Hello everyone, welcome to today's training. Today our topic is about single-axis motion control. I will introduce today's contents in these three parts. First one is single-axis management function block. Second part is single-axis motion function block. And last I will show the relative position and the absolute position in PLC program. Please notice that here are our software help menu and the programming menu of 6V. You can download these two menus in this link to study our 6V. First part, single-axis management function block. Look at this function block. This is used to enable our servo. We can see here are four input of this function block. This one is the axis ID, and this is used to enable servo, and then these two enable positive and enable negative. It means whether motor could rotate forward or rotate reverse. Usually we enable these two. And in this output side, we can see here is error ID, and the user can check the error with this table. This table is in our 6V menu. We can see 0 means no error. Okay, and this reset function block is used for servo error clean. If we have error of the axis, we need to first soften the problem, and then we can use this reset function block to clean the error. Here is axis ID, and this is execute. This two function block is used to reach the speed and the absolute position of our servo. It's easy to understand. We can see we just need to bind the arrow axis to this function block and enable this input. Then we could check the speed and the position on the output side. This function block set position is used for servo position set. We input servo position in this position, and for this relative, if we set it as true, it means absolute position, and if we set it as false, it means it's relative position. This execution mode is not used now. It is in developing, and also we need to bind the axis ID. Here are other function blocks of axis status readings. You could check this function block in details in our menu. Okay. And the 6 we have totally 11 single axis management function block for now. Next part is single axis motion function block. For this function block, we code it as management function block. You can see there this function block is used to, for example, enable servo, clean error, read speed, read position, and some read other code, read other status or read other parameters. So we call it as management function block. And the motion function block is used to control the motor to rotate. You could see these two function block, move relative and move absolute. You could see here are many input of these two function block, but they are similar. For example, this move relative equation is equal to random relative motion, and this function and this input continuous update. It is, for example, if we set it as true, then during the relative move, we could change this parameter real time, and the motor will change the motion real time. And if we set this continue update as false, then we can set. We also can set these parameters during relative moving, but these parameters will not take effect directly. They will take effect in next moving. Okay. Distance is our relative position, and this is our speed, acceleration and deceleration. This jack is means the rate of change of our acceleration and deceleration. Okay. And the XID is used to bind our axis. Here we could see here have a buffer mode. This buffer mode, we have 5 buffer modes of our function block. And I will introduce this function, this buffer mode in the future. And you can also start it then in our 6V manual. In today's program, I will use it as mode 0 or mode 1. For example, the mode 0 means, for example, we have a function block is running now, and if we execute another function block and that function block buffer mode is 0, then the current function block will stop directly and to run the next function block. If we set this buffer mode as 1, it means when the current function block is running, we run another function block with buffer mode 1. Then the other function block will run after current function block is finished. Okay. And for this move absolute function block, the input side is almost same, so I will not introduce that again. Please note that acceleration and deceleration can't be set as 0. Otherwise, we will have an error. And this continue update I have already introduced. Also, this jack I also have already introduced. Okay. Next, these two function block. First one, move additive. This function block is used to increase the distance of motion based on current motion. For example, this is our current motion, and when the motor when the motor in this side, in this part, in this time we execute this move additive function block, then the motion will change to the new motion. For example, here if we set its distance as 100, speed as 10, and the acceleration deceleration as 1, the movement will change to this, like this. For example, this is speed, and this is time. So this part is our new distance we set in this function block. For example, here we set 100. So in this point, motor will begin to run with our new speed. For example, here we set this new speed as 10. Then this is 10, and maybe our first motion is speed is only 8. In this point, if we executed this function block, our speed will increase from 8 to 10. 10 is the parameter we set in this function block. Will increase to 10. And for this acceleration is depend on this parameter. Okay. And this deceleration is dependent on this parameter. And from this point to stop, the movement distance is dependent on this parameter. Okay. And this is our buffered 0. As I said just now, if we use buffered 0, the next function block will be executed directly, and then the first function block will be stopped. It's a little like an interloop. And also, and here, if we set the buffer mode as 1, wait a moment. This is our current function. This is our current motion. And in this point we executed this function block, and we use buffer mode as 1. Then the motor will continue to finish the current function, the current movement, and here stop here, and then begin to execute our new function block, this one. So this is the difference between buffer mode 1 and buffer mode 0. Okay. And this move supreme poster. This function block is used to increase speed of motion based on the current motion. This two is a little similar. This one is used to add another distance, but this one is this one have already this one also change the speed. Also, let's take an example. This is our current movement, and in this point, we executed this function block and we set the buffer mode as 0. 0 means we will execute this new function block directly, and we set this parameter, for example, as 5. It means for example, our current function block speed is 3, and in this point, if we executed this function block, then the speed will increase from 3 to 8. Okay, from 3 to 8. This is 8. And continue to run and stop. This acceleration and this deceleration, these two is depend on these two function depend on these two parameter. Okay, and for the new motion, the distance is depend on this parameter. These two is a little different. And for this parameter, a speed diff. For this parameter, we could also set it as, for example, set it as this one. It means our speed will change from 3 to 1. For example, like this. Okay. And both these two functions could be executed several times. For example, we have a current motion range 10 distance, and during the motion, we executed this function block 5 times. Then our finally distance will stop at 510. We can execute this function block several times. Also, this is also extend. For example, our current speed is 5, and we executed this function block, for example, 3 times. Then our speed will increase to 8. If we set this speed different as 1, we will get speed 8 finally. And the next function block, this is stop. This one is easy to understand. We could see here are only three parameters in input. First one is execute, and the second one is deceleration and jack. and the axis ID. This function block is used to stop axis and with the setting deceleration and the setting jack. Okay. In our last part, I will introduce relative, absolute, and the relative position and absolute position in details. First, before programming, we need to add our motion control axis. And here in Program Manager, is a case we need to right click and select a new EtherCAT session. And then our motion control axis will be added here. Double click our axis, motion axis, and in this unit conversion setting. Unit conversion setting. Here we have this setting used to set our unit of motor movement. For example, if our motor is 17 bit, it means one rotate will have this number pulse. And if we set it as 1 unit, it means motor will run 10. For example, motor will run 10 rotates, 10 rounds if we set the distance as 10. And the motor will run, for example, 5 load per second if we set the speed as 5 units. We can see here all this deceleration and this distance, acceleration, and the speed, all these parameters use this unit. And also if we set this pulse, this number pulse as 2 units. It means if we set the distance in function block as 10 units, then the motor will run 5 rounds, because 1 load is 2 units, so 10 units is 5 rounds. Okay. And now let's check the program. Okay. Now let's enable our server first. Now server is enabled and here are no error. And use these 2 function block to read the position and the speed of our motor. It's 0 now. Then let's try these two absolute and relative first. For this relative move, we set the distance as 50 and the speed as 3, acceleration and the deceleration as 1, and in the enable this function block. And from here, we could see the speed is 3 now, and the motor will stop at 50. And stop. Now we could run this relative move again. Also the speed is 3, and the motor will stop at 100 distance. Okay. Now let's try absolute move. We set the position as 40. And if I move this, and if I executed this absolute move, the distance of the motor will be changed to 40. Let's try. We could see the distance is reduced, and then the speed is from the speed we could see the motor is in reserve rotate, and the stop and 40. For this set position, for example, we set the position as 20 and executed this function block. You can see the position is changed to 20. Okay. And now let's try these two. These two, move additive and move self-remote post. First, we set a distance as 100, and the current distance is 20. So after this relative move finishes, our distance will be 120. The position is increasing now, and during this function running, if I executed this move additive function block, we could see the last position will be 150 because we executed because we use this function to add the distance, to add 50 distance. We could see it is 150 now. Sorry, 170 now. Also, let's set a bigger distance, 200. So, and I will run this relative movement. 200 at 170 it will stop at 370. And during the motor running, if I executed this function block, our speed will increase from 3 to 5. You can see speed is increased from 3 to 5. And also please check the finally position. You can see it's stop at 420 because 370 at 50 is 420. So this function can change the current speed and also add the distance. Okay. Okay, that's all today's content. I will send the program to our group, and our next training is about VD2 because we have a new firmware of VD2 and add some new functions. I will introduce these new functions in our next training. Okay, that's all. Thanks for your watching.